So if we're trying to figure out the degree of unsaturation of a hydrocarbon molecule, we basically want to know how many either pi bonds or hydrocarbon rings are present in the molecule. So we're trying to figure out the degree of unsaturation. And basically the two things that cause a hydrocarbon to be unsaturated are pi bonds, which are double bonds, and rings. And the classic example of a ring is like your cyclohexane ring. And so if we take the example of, say, ethane, which is 2 C's, and ethane is completely saturated, so it has the maximum number of carbons possible. Hydrogens possible. So carbon can make 4 bonds. There's 1 bond to each carbon, and then we have 3 hydrogens on top of it. And so this gives the molecular formula of C2H6. And so when ethane is completely saturated, when you have a 2-carbon hydrocarbon that's completely saturated, you have a total of 6 hydrocarbons. And the general formula for a completely saturated hydrocarbon is C and H, because hydrocarbon. And so say if we have n number of carbons, the number of hydrogens we would have if this is completely saturated is 2 times n plus another 2. And so in the case of ethane, we have 2 carbons, n equals 2. The number of hydrogens would be 2 times n, which is 2 times 2, plus another 2 is 6. And sure enough, we have 6 hydrocarbons. So again, ethane is completely saturated. And so if we have a molecule with 2 carbons that's unsaturated, we would introduce a double bond here. And so if we put the maximum number of hydrogens this can have with the double bond, it would only be 4. And so now we're down to C2H4. So here we can see it's obviously unsaturated because it has less than the maximum number. And so if we want to calculate the degree of unsaturation of this molecule, in order to do that, we need to take the maximum number of hydrogens possible for a 2-carbon molecule. So we've already established that's 6. So that's 6 is the maximum number. And then we take the actual number of hydrogens we have for the molecule in question. So in this case, it's 4. And so we would subtract 4 from 6. And that gives us 2. And then so the next step is we understand that for each degree of unsaturation, we lose 2 hydrogens here. So if we see the transition from here to here, we've added a double bond. Go from here to here. We've added a double bond, and we've clearly lost 2 hydrogens. And so the effect of adding this double bond meant that we lose basically 2 hydrogens. And so we would have to divide this by 2 because we lose 2 hydrogens for each degree of unsaturation we introduce. And so if we divide 2 by 2, we get 1. And so our answer is this is 1 degree of unsaturation. And alternatively, this could be a double bond or a ring. And so just doing this basic calculation wouldn't specify whether or not it's a pi bond or a hydrocarbon ring that is the cause of unsaturation. Although in this example right here, it's pretty obvious that 2 carbons can't make a ring by themselves, and so it would most likely be a pi bond.